Hello everyone, welcome to my YouTube channel. I am Dr. Injamamul Haque, currently working as assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. Today we will discuss the important topics, introduction to the hypothesis, testing and Z-test for large samples. This lecture is very important because it forms the foundation of statistical decision making, which is widely used in the research, engineering, data science and real world problem solving. In this session, we will mainly focus on the concept of hypothesis testing, null and alternative hypothesis, and the application of Z-test for the large samples. This concept will help you understand how to make the decision based on the data rather than assumption. So, by the end of this lecture, you will be able to understand the concept of hypothesis testing, formulate null and alternative hypothesis, and then apply Z-test for the large sample cases and intercept the result of hypothesis testing. Okay. Before going into the theory, let me ask you simple question. Suppose a company claim that their battery lasts 10 hours. Will you believe it directly? Of course not. You will test it using the data. This is exactly what the hypothesis testing does. It helps us make the decision, validate the claim, use simple data to infer about the population. So now we will define the hypothesis testing. Hypothesis testing Hypothesis testing is a statistical method that helps us to determine if there is enough evidence in a sample of data to infer that a certain condition is true for the entire population. So this is the definition of hypothesis testing. Now, what is the property of hypothesis testing? It is a fundamental tool in inferential statistics. It helps in making the decision based on a sample data, provide a framework for testing the assumptions and claim. So this is the hypothesis testing. Now we discuss about some example of hypothesis testing. Testing whether a new drug is more effective than an existing one, checking if a coin is biased toward the head or tails, determine if a new teaching method will improve the student performance or not, right? So these are some examples of hypothesis testing. So now after that we will discuss about some important about the hypothesis, the type of hypothesis, right? The hypothesis, first we will discuss about the null hypothesis. Okay, basically we will denote this null hypothesis as a H note. Okay, we will denote this null hypothesis as a H note. The null hypothesis basically represent the default assumption. It assumes no effect or no difference. Okay, that is basically null hypothesis is a statement of whatever the given the raw statement, or you can say that the by default statement, and it is no effect or no difference. And this means in example we can say that the mean weight of the apple is 150 gram. So this is the what? This is the raw statement, this is the original statement, default statement, and this will be what? Null hypothesis. Okay. Now there is another hypothesis, that is alternative hypothesis. This hypothesis represent what we trying to prove. This represent what we trying to prove. This is contradict the null hypothesis. For example, previously we have taken that the mean weight of the apple is 150 gram. But in case of alternative hypothesis, it will be what? This is not 150 gram. If we taken in null hypothesis as a what? The mean weight of the apple is less than 150 gram. In that situation, the alternative hypothesis will be what? Strictly greater than 150 gram. That is, alternative hypothesis is just the complement, or you can say that the opposite statement of null hypothesis. This hypothesis always contradict the null hypothesis. So this is alternative hypothesis. Now we will discuss about the test of hypothesis. Now we will discuss about the test of hypothesis. There are two type of test, one tail test and two tail test. So one tail test is what? If the parameter given is a greater than or smaller than the value, then you can say that that is one tail test. That means if in a question if the claim is given in the form of greater than or less than, in that situation that test will be what? One tail test, right? And if the parameter is different from the value, that is two tail test, if the parameter is different from the value, that is a equal to mu not equal to 50, right? In that situation you can say that two tail test. Or also you can say that if the claim is given in the equality form, in that situation the test will be two tail, right? In a question, if the claim is given as a greater than or less than form, then you can decide that problem will be solved by one tail test. And if the claim is given in the form of equality, in that situation the two tail, that problem will be solved by two tail test, right? So this is all about the one tail and two tail test. Now we discuss about the left tail and right tail. Suppose that the test is one tail, then it will be either left tail test or right tail test. Test whether a parameter is significantly smaller than the hypothesis value. That is, if suppose that null hypothesis mu is greater than mu naught, then alternative hypothesis will be what? Mu is strictly less than mu naught. The critical region is in the left tail of the normal distribution. In this situation, you can say that mu is strictly less than mu naught. This is left tail test. And if test whether a parameter is significantly larger than the hypothesis value, that is, if you take the null hypothesis as a mu less than equal to mu naught, but alternative hypothesis is a mu greater than mu naught, in that situation you can say that this is the right tail test. This is only for the one tail test. It will be either left tail or right tail. Okay. So this is all about the left tail and right tail test. So now also here comparison operator. Suppose that if you take that null hypothesis as a equality, in that situation alternative hypothesis will be equal to what? Not equal to. If the null hypothesis is less than equal to, then the alternative hypothesis will be what? Greater than. If the alternative hypothesis is less than, then the null hypothesis is greater than equal to, right? So in case of equality and not equality, here always we will take this as a two tail test. And if it is greater than or less than type, that will be the either left tail test or right tail test. Okay. So this is all about the two tail test and one tail test. Okay. So now we will discuss about the procedure of hypothesis testing. First, what things have to do? First step, define the null hypothesis and alternative hypothesis. First, we will have to define the null hypothesis and alternative hypothesis. How we will define this one? If the question, the claim is what? If the claim is are in the given in the form of what? Equality, in that situation we will take as a null hypothesis is equal to an alternative hypothesis is equal to claim is not equal to. Then we will choose the significance level for the one tail test and two tail test. Then select the appropriate test statistics that will be discussed in the later, and then we will compute the test statistic value. Then we will compare this value with the critical value, right? Then we will decide it will be reject or fail to reject the H naught. Fail to reject means what? Accept the null hypothesis. Okay. So what things have to do? First, we will define or determine the null hypothesis and alternative hypothesis. Then we will choose the significance level. Then we will find the value by using appropriate test statistics. Then we will compare this test statistic value with the critical value. Then we can decide if the null hypothesis will reject or fail to reject or accept. Okay. So these are the procedure for the hypothesis testing. So now how we can select the significance level alpha. The significance level alpha is the probability of rejecting the null hypothesis when it is true. The common choice are 0.05, 0.01, 0.10. Okay, lower alpha means strict criteria for rejecting the H naught. So this is the about selection of significance level. Now we will discuss about the test concerning the mean of normal population for the large sample space. What is the meaning of large sample space? Large sample means what? Large sample means the number of observation is greater than equal to 30. In that situation, we will use the Z statistical test. Now we will discuss about the Z statistical test. So Z statistical test is what? The Z statistical test is test under the parametric statistics which is applied to the normally distributed data. It is uses the two population parameter. First one is the mu, second one is the standard deviation. It is used to compare the two means, the sample mean and the perceived population mean. It is also used to compare the two sample mean taken from the same population. When the samples are equal to or greater than 30, the Z test can be applied in two ways. One simple mean test, two simple mean test. So first we will discuss about the Z test for one simple mean test. In the next video we will discuss about the two sample mean test. Okay. So now we will use the critical value of Z test if the level of significance is given as 0.01, and for the one tail test this is equal to plus minus 2.33, and for the significance level alpha equal to 0.05, for one tail it is equal to 1.645, and this value for alpha equal to 0.01 is for two tail 2.575, and for one tail, no, for two tail for alpha equal to 0.5, this is equal to the 1.96. So this is the critical value from the Z distribution table. You can say that from for the Z test. Okay. So we will use this critical value of Z for two tail and one tail test. Okay. So now we will discuss about the Z test for one sample group. The Z test for one sample group is used to compare the perceived population means against the simple mean X bar. Okay. So now we will when this Z test is used for one sample group, the question is about that. The one sample Z test is used when the sample is being compared to the perceived population mean, and if the population standard deviation is not known, that is sigma is not given, the sample standard deviation can be used as a substitute, right? So now we will define, we will discuss the formula for calculating the Z value. There will be two cases. One case if the sigma is known. If the population standard deviation sigma is known, irrespective of the sample size n greater than 30 or n less than 30, in that situation, we will use Z equal to X bar minus mu by sigma by square root of n, right? In second case is what sigma is unknown and n is large sample, that is n greater than 30. If the population standard deviation is unknown and sample size n greater than 30, then we will use Z test as a what? Z test Z equal to X bar minus mu by S by square root of n. Then what is the final decision? What will be the final decision? We will find the value from the Z statistics by using this formula. If the Z calculative or Z statistic value, mode of Z statistic value is less than Z alpha, then we will accept the null hypothesis H naught. If the Z statistic value or Z calculative value is strictly greater than mode of Z alpha, then it will reject the null hypothesis H naught. You got it? What is the procedure to finding the hypothesis testing for the mean of large sample space? First, you have to decide the null hypothesis and alternative hypothesis. In the second step, what things have to do? In the second step, you have to find the value of Z statistics, or you can say that the calculative value of Z by using this formula. Then you have to take the value, critical value from Z as we have discussed in the previous table, right? Then you will decide if mode of Z is strictly less than Z alpha, then we will accept the null hypothesis H naught. that is the statement H naught is true. If Z alpha is strictly greater than Z alpha, then it will reject the null hypothesis H naught. That means it will contradict the null hypothesis H naught. Okay. So this is all about the hypothesis testing. Now we will understand this concept with the help of some problem, right? Okay. So now problem first. A company claimed that the average lifetime of its light bulb is 1200 hours. A sample of 40 bulbs has a mean life of 1180 hours and a standard deviation of 100 hours. Then test the claim at alpha equal to 0.05. Right? So in this question, what things have been given? So now we will solve this problem step by step. Okay. So in step 1, we will step 1 we will define the null hypothesis and alternative hypothesis. As you can see that the claim is what? A company claim that the average lifetime of its bulb is 1200. That is, this the claim is inequality. Claim are given in the form of equality. That's why we will take first as a null hypothesis H not equal to 1200, right? So what will be the alternative hypothesis? Just the complement of H naught. So that will be what? This equal to 1200, right? H naught HA not equal to 1200. Now, as these are given in the equality form, that's why this will be what? One tail or two tail test. This will be two tail test. This will be two tailed test, right? Why? Because you can see that the null hypotheses are given in the form of equality. That means it have both the possibility, either it is less than equal to 1200 or greater than equal to 1200. That's why this is two tail test, right? What is second step? What is the significance level? Significance level is what? Significance level alpha equal to what? 0.05, right? Now we will find in step 3 the Z statistic value. For the Z statistic value, what is given to you? The x bar equal to what? 1180, mu equal to what? Mu equal to what? 1200, right? This is mu. And what is the value of sigma here? Sigma equal to, you can see that in this question the sigma standard deviation is equal to what? 100, right? And what is the value of n here? 40. Now we will apply the formula to finding the what? This is what? This is step 3 to finding the Z statistics value, right? So now we will apply the formula. What is the formula for Z statistics? Z statistics, or you can say that this is Z calculative value equal to x bar minus mu by sigma by square root of n. You can see that in this question n is what? N equal to 40, which is greater than equal to 30. That's why this is the large sample, right? So now we'll put all the value as given here. X bar is 1180 minus mu is 1200, right? By n is equal to what? Sigma equal to what? 100 by square root of 40. So this is equal to the what? By calculating we can find that this is 1.26. Okay. Now from that table, what is the Z critical value? From step 4, this is step 4. Z critical value is what? Z critical value is given as 1 plus minus 1.96 put to 2 tail test, right? At alpha equal to 0.05. So that's why we can see that mode of Z calculative value is less than what? Z alpha, that is Z critical value. So that's why it will reject or accept. As we can see that Z calculative value is strictly less than Z alpha. So it will it will accept the null hypothesis H naught. So this is all about the problem to finding to determine the hypothesis testing, right? Now we will discuss another problem for the more clarity. A factory claimed that its machine produce item with an average weight of 500 gram. A sample of 30 items has a mean of 490 gram with a standard deviation of 15 gram. Test at alpha equal to 0.01. Okay. So now again you can say that claim is the average weight of equal to 500 gram. So that's why it will be two-tail test. Okay. So now we will solve this problem step by step. In step 1, what is, we will determine the null hypothesis. Null hypothesis will be what? Mu naught equal to 1500. What is the alternative hypothesis? Mu naught not equal to 1500. Okay. In step 2, what is significance level? This will be what? Two tail. This will be what? Two tail. Right. In step 2, what is significance level? What is significance level? So you can see that the significance level alpha equal to given 0.01. 0.01. Now in step 3 we will find the value of Z statistics. Okay. So Z statistics, here what is given? X bar equal to what? Here X bar equal to 490. Okay. And what is the value of mu naught? This is equal to the what? 15. Sorry, this is not 1500. This is 500 in the given in the question. Right? This is mu is a 500. So mu naught is equal to the what? This is 500. Now what is the value of sigma? Standard deviation is given. This is equal to the 15, right? And n equal to the what here? N equal to 30 in this question, right? Now we again apply the Z statistics formula for the large sample space. What is that formula? Z statistics, or you can say that Z calculative value. This is Z statistics value. This is equal to the what? X bar minus mu naught by sigma by square root of n. So x bar equal to the what? 490. Mu naught is equal to what? 500 by sigma equal to the what? 15 by square root of 30. By calculating this value, we can get this is equal to 3 point minus 3.65. What is the critical value? This is again the what is the in step 4. What is the Z critical value? Z critical Z critical value equal to what? This is equal to Z critical value. You can see that for two tail test, this is given as plus minus 2.576. Okay. So now we can see that the mode of Z alpha, sorry, mode of Z statistics or Z calculative value is greater than Z alpha, greater than Z alpha. So it will reject the null hypothesis H naught. Okay. So this is all about the null hypothesis testing at alpha equal to 0.01. Okay. Why? Because you can see that Z static value is 3.65. This is greater than Z alpha. That's why it will reject the null hypothesis H naught. Okay. Now again I am discussing the another problem. In this problem, a researcher claimed that the average height of the student in a university is greater than 170 centimeter. A sample of 50 students has an average height of 172 centimeter with a standard deviation of 5 centimeter. Test the claim at alpha equal to 0.05. As you can say that the claim is here is greater than 170 centimeter, right? And already we have discussed about that. If the claim is greater than or less than, in that situation the problem will be for one tail test, right? And this is what? This is right tail test. Okay. And also the number of observation is n equal to 50. That's why it is for the large sample. And the average height of this student is also given, that is x bar equal to 172, right? And the standard deviation sigma is given 5. Now we have to check the claim at significance level alpha equal to 0.05. Now we will solve this question step by step. Okay. So here first we will choose, as already we have discussed about that, if this is the greater than or less than type, in that situation first we will choose claim as a alternative hypothesis. Okay. So step 1, what is alternative hypothesis? HA mu naught is strictly greater than 170. So what will be the null hypothesis? H naught. This is the just complement of this one. So that's why this is mu naught less than equal to 170. Okay. So this is what? One tail test. This is what? This is one tail test. This is one tail test. Okay. So this is one tail test. Now what is the value of, in step 2, what is the value of alpha? Alpha, that is significance level, significance level alpha equal to what? 0.05, right? So now in step 3 we will find the z calculative value or z statistic value. In step 3 we will find that z statistics value, test statistics, also known as test statistics. This is test statistics, right? So we will find that z calculative known as z statistics, right? This is equal to the what? The formula x bar minus mu naught by sigma by square root of n. Okay. So now in this question, what is given? In this question, what is given? X bar equal to the 172, sigma equal to what? Standard deviation is 5, n equal to what? 50, right? So what is that value? So Z calculative value or Z statistics is equal to the what? Z statistics equal to 172 minus, this is mu naught is 170 by sigma is 5 by square root of what? 50, right? So this is equal to the 2.83. Now what is the critical value? Step 4. What is critical value? What is Z critical value? Z critical value from that table, as we have discussed, that for alpha equal to Z critical value, Z alpha equal to what? Z 0.05. This is equal to 1.645, right? So here also we can see that the mode of Z calculative value is greater than Z alpha. So that's why what will be it? That's why it will reject the null hypothesis. It will now, so it will reject the null hypothesis. Okay. So this is all about what? This is all about the hypothesis testing for the large sample space when one mean of group is given, when one mean is given, right? In the next lecture, we will study about the hypothesis testing of equality of means of two population in the next video. So if you found any helpful things in this video, kindly like and subscribe my YouTube channel and also share this video to your friends, and we will meet in the next video. Thank you.